Hello all. So today we will solve one of the Leetcode problem. The name of problem is majority element 2. The problem says that given an integer array of size n, so we have given an integer array which has the size of n. You have to find out all the element which present more than n by 3 times. So this was the problem statement. Okay. To solve this problem, let's take one example. So in this example, if you look, the length of this array is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length of array is 9. And you have to figure out the elements which are present more than n by 3 times. And we have to take the float of it basically. Okay. So here n is 3, so 9, n is 9, so 9 by 3 is 3. So the element which are present more than 3 times, which means any element which are present at least 4 times, we have to return all this thing. So if you look at first element, which is 3, so 3 are present 1 time, 2 times, 3, 4 times. So in our result, 3 will be one of the answer. 2 are present 1 time, 2 times, 3 times, 4 times. So this is also present 4 times. So 2 will also come. And then we have 1 also. So 4 also, but 4 is present only 1 time. So we will not return it. So the answer for this will be 3, 2. Okay. So we understood problem like we have to return majority element which are present more than n by 3 times. Let's suppose my n is 10, then 10 by 3, which is 3 point something, but we will take the float of this, which is basically 3 only. So in that scenario also we need to figure out any element which are present more than 3 times. Okay. Now to solve these problems, we know there is very similar problem to this also exists, which is figure out element which are more than n by 2 times. But in those problems, we were sure that any element which are present more than n by 2 times, so it should be only the answer should return single element. Why? Because if anything present more than n by 2 times, then there is no possibility of any other element will present, right? And in the case of n by 3 times, the answer and this single element is can have possible. It's not sure that there should be any answer for it or not. Okay. In n by 3 times, if any elements are present more than n by 3 times, and it can be a double only. There are only possible 2 element. Maximum 2 element can be written. Okay. 1, 2, something like example. Okay. So you got this. If n by 2, more than n by 2 elements we have to figure out, there is only single answer possible. And the n by 3 times, the 2 elements can be the answer. Okay. Now let's talk about the brute force approach. Let's talk about the brute force approach. Okay. The first things comes into our mind that take each element, find the number of occurrence, find the number of occurrence. If number of occurrence greater than n by 3 times, we will append this into our result and we will return it, right? To solve in this way, the time complexity will be uh, O of n square. Why? Because first we will take each element and then we have to calculate the count, we have to go through till the end, right? And the space complexity for this scenario will be O of 1. Okay, so we got this problem, like, okay, how we will solve this. Yep. Okay, now let's talk about that is there any other way to solve this. So there is one better approach than this. Let's look at the better approach. The better approach is related to hash map, which says that you basically create a hash map, which will be the element and their count. So where in these scenarios, if we have element 3, 2, 4, and we will return the count. So the count 3 are present 4 times, 2 is present 4 times, and 4 is present 1 time. So basically we will create this hash map, and we apply one condition that if it's present more than n by 3 times, then we will return that element, right? Okay, so we got this. The time complexity to solve this problem is O of we have to return to the end O of n, and the space complexity will be O of n, because we need to calculate we have to create one hash map. Now let's talk about the optimal way to solve this, the most optimized way to solve this. For this we have we use one algorithm which the name is very famous, Moore voting algorithm. Okay, so in the starting I covered one thing, that if you need to figure out n by more than n by 2 times, the answer should be single value, but if it's n by 3 times, there is possibility of answer should have maximum of 2 element, right? Here single element and here 2 element. So we got we need 2 elements. So what we will do, we will create a 2 variable. Let's give them a name of let's okay, let's give them the count. Let's take for that to calculate, we got it right, we need 2 elements only, the answer should have in 2 elements only. So let's take that 2 elements are m1 and m2. So m1 will be majority element 1 and m2 will be the majority element 2, and initially we will keep it -1 because, but -1 can be the element, so we will keep it as a none. Both are none initially, and we have the count 1 of majority element 1 for, and count 2 for the majority element 2, and the both count initially will be 0 0. So it says basically start from the first position. Okay, so initially I will be at 3 position. Okay, I will be at first position, which is 3. So it says that first you will look that whether the count of 1 is 0 or not. So the count of uh, 1 is 0, so we will include this as a majority element 1. So our majority element now become 1. Sorry, the majority element become 3 and my count of 1 become 1. I will go ahead at 2. Now I will look at 2. Since my count 1 is 1 and sorry, my majority element is 3, I will look at majority element 2, which is none. So I will assign this as a majority element 2 and the count will change to 1. Now I will move ahead and I will be at a 3 position. I will look like okay, so if it's already present or not. I see okay, my M1 which is 3 I have, so I will update my occurrence of majority element 1. I will move ahead at a 4. I will see okay, whether it's a M1 majority element M1, no it's not. Whether it's a majority element M2, no. So what I will do, I will decrease the count of occurrence, so it will be 1 and it will be 0. Now I will move ahead at a 2. I will look at this and I will say whether it is equal to a majority element 1 or 2. Yes, it's equals to a majority element 2. I will increase this count. Similarly, I will go ahead. This majority element will increase. I will again look 3. This majority element will change. I again look at 2. And now again it's 3. Okay. So I got this, like I got at the end of the day my both two majority element and their occurrence. But I need to be here make sure that both the majority elements are actually greater than equals to. So I have to do validation. So to do the validation, what I will do, let's what I will do to complete my validation, I will run a loop once again, okay, from starting to end, okay, and I will say that okay, if within my array how many times the M1 and M2 are present, and if that count is greater than n by 3 times, I will append that element to my result, and at the end of the day I will return it. So this is how we will solve this majority element problem. So this use the Moore voting algorithm, which is very important. Okay, it's use Moore voting algorithms. First we have look at the brute force approach, which is the time complexity of O of n square and the space complexity of O of 1. Then we will look at the better approach, which use the hash map. To first we create this hash map, but the problem with this is that the space complexity took the O of n. So to solve this within okay, so this problem, the majority element now use the time complexity of O of n, but here we cannot save. The time complexity was O of n only, but in the space complexity we are able to solve within this O of 1. Okay, so then we will move to the Moore voting algorithm. In the Moore voting algorithm, we look at the most important part for this to understand this. If n by 2 more than n by 2 majority element, you have to figure out the answer should be in the single element, but if more than n by 3 someone asks, then the answer will be 2 element. So for this is n by 3 times, we need 2 elements, so that's why we have created 2 variables for the majority element and 2 variables for the count, and then we use this algorithm to determine whether the majority elements are present or not, and then we have validated using one single loop to count the majority element occurrence and validate that it's present n by 3 times, more than n by 3 times or not. If let's suppose someone in the future says that we have to figure out more than n by 4 times, during that times we have to take the basically 3 element three elements are possible. So in those scenarios, three variables will be there, A, B, C, and the count, and we have to apply this algorithms. So this is all we have majority elements problem 2. I already write a code for this. So this is the code. So let's look at this. Hmm, let's copy it. Yeah. Hmm, okay. Yeah. So this is how we wrote a code. Basically, what we did here, we have created two a majority element m1 and m2. Initially we keep it as a none, and we also create the occurrence of majority element c1 and c2 respectively, and then we have one loop for I nums. Nums is our array. Initially we put a one condition which says that which basically says that if my I, which is basically the element, if my I equals to the majority element, I will increase my occurrence of uh, majority element 1. If my element is majority element 2, I will increase the count of majority element 2. I will increase here C1 by 1 unit and here by C2 1 unit. And if let's suppose we are at a very initial stage where the C1 and C2s are 0, so what I will do, I will say my majority element 1 is the equals to the element, and here I will say my majority element 2 are equals to the element, and uh, sorry, yeah, and I will say my C1 equals to the 1 and C2 equals to the 1. Okay. If there are no such condition about to this, what I will do, let's suppose I have figured out one element which is not equals to the majority element 1, not equals to the majority element 2, and my occurrence of majority element 1 and majority element 2s are already not equals to 0, then I will decrease the occurrence of my uh, count which is already there. If I not do this, what happen? I will never figure out, because let's suppose I will never able to figure out any new elements, right? And after solving all these problems, I will get my majority element 1 and majority element 2 here. After that, I will validate it. After that, I will validate it that whether my majority element 1 and majority element 2, the occurrence are greater than equals to n by 3 times or not. Sorry, here basically I'm just calculating the number, and yeah, its total part is validation, and at the end of the day I'm validating and I'm returning my result. Okay, so this is how we wrote a Python code. I hope you like our solution. We will meet next time.